Good morning. We continue the program. I'd like to introduce the next speaker, Mr. Péter Galambos, who is the director of the Óbuda University Antal-Bejci Center for Intelligent Robotics. And Péter will talk about the robotization for food industrial SMEs. Péter, the floor is yours.
Thank you very much, András, for the introduction. I'm Péter Galambos, the director of the Antal-Bejci Center for Intelligent Robotics, and I'm going to present you some of the useful robotization technologies. Sorry for, I try to fix my audio. Okay, I hope it's gonna work. Okay, so let me share my screen. Okay, do anyone see my screen now?
Még nem látjuk. Most jó.
Good. Robotization for food industrial SMEs. This is the title of my topic, and I'm gonna show three kind of interesting robotization setups. I want to emphasize that these setups are not really deep rocket science, except of one, which means the second one actually, but rather off-the-shelf solutions that could be integrated directly into food industrial solutions. But first of all, I would introduce our laboratory in a more general way. So the laboratory is entitled by Professor Antal-Bejci, Tony Bejci. Probably he was the most famous Hungarian roboticist. He worked for more than 25 years for the NASA JPL laboratory in Pasadena. His main results was in teleoperation and telepresence systems, especially in space robotics. We are very proud of him, and according to his research activity, we are focusing basically on teleoperation and telepresence, advanced applied robotics, cloud robotics, and medical robotics. And in advanced applied robotics, food industrial applications holds a quite large spectrum. Our main topics, I divided our focus areas in two columns. On the left side, there are the medical robotics stuff, and on the right side, we have the applied robotics focuses. I only emphasize some of these items: system design, future of manufacturing research, control engineering aspects, machine learning, and mainly the proof of concept validations of new technologies. It's a kind of offer to the community as a living lab that we are able to perform proof of concept validations of sensor technologies, robot technologies, or even more complicated processing technologies. These are some live pictures from the the lab. I shot this photo last November. Maybe one of my talented students worked overnight to finish his master thesis. So I'm also very proud of my great students. We often invite high school students to the laboratory to give them introductory lectures on different aspects of robotics. It is very important to do this in order to ensure the new generation appearance in our university and in the technical community in general. We very committed in real-world problem solving and prototype building. That is why we are operating a virtual or not virtual but really physical prototype laboratory in which I took this photo. I will introduce it later on. And in international education activity, we often organize summer schools and other student exchange programs in which last November and this March, just before the pandemic, we organized a student exchange program with the Japanese University, Shibaro Institute of Technology, and hopefully we can practice it in the future after the pandemic. Yeah, these are the Japanese students on the top of a train, which is actually just in front of the university building. Our mission is basically the end-to-end innovation model, which means that we cover the innovation process from the formulas to the prototypes, and our staff is built up accordingly. We do have mathematicians, physicians on board, as long as engineers in mechanical, electrical, and software part of the problems. So as a result, we can provide a complete service to our partners, from exploratory research to practice-driven R&D and system integration. Robotics is a megatrend, as we know, so it is very hard to talk about pure robotics. As we learned from today's webinar, from the BME, from the ALTA presentations, robotics cannot be separated from other parts of Industry 4.0. We can only handle it as a co-evolving technology spectrum, and Internet of Things, robots, artificial intelligence, virtual and augmented reality along blockchain. Everything is here. It's a very dynamically growing market. So we definitely have to be on this trend. The yearly market growth is continuously over 15% per year. So it's a strong trend. Our R&D staff contains 4 postdoc scientists, 6 PhD students, 8 graduate students, which I usually call resident students, who are still in a student status, but working with us on our project, even with a contract. So let me say they spend about 12 to 20 hours a week to join our research activity. We also have 4 full-time engineers and the necessary administrative staff to cover the project necessities. Internationally, we are quite active in several organizations, mainly in IEEE, Robotics and Automation Society, Systems Man and Cybernetics, and Industrial Electronics societies. We are also a member of the EU Robotics ASBL, and we hosted several programs in the frame of this public body. That is why we try increasing our activity in Horizon 2020 and the upcoming framework calls and projects as well. We have, in the medical era, we have a strategic partnership with the Austrian Center of Medical Innovation and Technology. Standardization is important in Industry 4.0 and robotics. That is why we maintain a strong activity in different ISO and IEC standardization bodies. And to turn on the today topic of this webinar, we believe that the big meeting is what is very important currently. The latest AI methodologies, latest AI technologies moves into the brain of robots, which represents the cutting edge mechatronics. As we know, there are leading companies all over the world who can provide very, very dexterous robot mechanism and control electronics alongside. But the main question is how to control the latest mechatronics in order to achieve the real world problems in the different industries, including the food industries. My favorite example is that you can buy now a 5-finger gripper in any sort of robotics manufacturer or robotics web store. So it is easy to buy a 5-fingered robotics gripper, but currently nobody knows how to control the 5-fingered gripper in order to perform useful tasks in real-world situations. So, but now researchers, including us, working very hard on this serious issues, how to control the dextrose manipulation, and sooner or later these real-time design, real-time planning technologies will be available, and we would like to be on the start line to integrate those technologies in industrial solutions. Today we are gonna show 3 different topics. The first one will be the manipulation of fruits and vegetables with robotics hands. This is not really a research topic, but it's a proof of concept. So with this topic, I would like to introduce you what I mean under a proof of concept validation. Testing a new technology without involving expensive industrial resources, rather use a living lab to try out a new gripper provided by a company. Actually, it's a real situation. Now we are testing an on-robot soft gripper. If it is capable of really manipulating fruits and vegetables without harming the objects, or not. So we are looking for the answers with this test. The second topic will be the demonstration of the RoboChair project, a gripper design for the intestine removal during the pork meat production process. This is an EU H2020 project. Hopefully I can show you really interesting stuff from the results. And as a third demonstration, it's not a deep rocket science. We are gonna decorate a cake, a chocolate cake, using a collaborative robot, just to demonstrate how to use such a robot technology, affordable robot technology, to make low-scale production in, for example, the conditories or rather food production where the cake decoration is a problem. Okay, so let me change my video source and audio source to my handheld camera. Yeah, I'm in a virtual space, so I will show this later on. And now okay, so Bianca, can you please switch my mobile camera to the audience? Okay, I think it's working now. So this is our test platform here, what you see, and this is my colleague Sándor Tarsoly, a mechanical engineer dealing with robot programming for several years now, and he is the guy here who is responsible for such a proof of concept validation and investigation. Okay, so what we see here is the soft gripper from OnRobot company, which is a leading manufacturer, leading technology developer, and they just rolled out this gripper. We are testing how to grab different fruits and vegetables with this.
I'm sorry to interrupt you.
Okay.
But maybe it is only me, but I don't really see anything outside of only your profile picture.
Okay.
But maybe it is only me.
Bianca, this is my moving camera, the IROB cam.
I mean, it's working properly for me, so the
okay. Spotlight video.
I also see it.
Yes, I can see properly.
Okay,
so
great.
Not clear what is the problem.
Great, so it was not a general problem.
Well,
now it works by me too, sorry.
Okay, thank you for the feedback. So as you see, we place different vegetables and fruits to the pickup position. Then the robot perform the pick and place activity through this soft gripper, which is actually a very simple mechanism. There is a soft membrane with four like a finger and one linear actuator in the center of the mechanism actuates this soft body, which is able to grasp the various fruits without harming the surface. Okay, the robot itself is a universal robot, UR16, which is a so-called collaborative robot arm. And we can conclude that in certain situations, this robot soft gripper performs quite well. The grasp is quite stable. I try to get out these vegetables from hand. Okay, so it's I manage it, of course, because it's a soft something, but anyway, the grasp is quite okay. So without external intervention, it holds very well. Okay, I don't want to use more time on this, but we have an ongoing project in partnership with a large mushroom manufacturer or producer, mushroom producer, and the task here is to harvest the mushrooms through robotic technology. We are not very sure that this certain gripper is the best suited tool to harvest the mushrooms, but we will test multiple options to solving this problem. This is one option. There are different type of grippers that could solve the mushroom harvesting problem. What is the difficulty here? As you see, the mushrooms are touching each other. Those are very closely growing to each other, and it is quite difficult then to grasp a mushroom without pushing the other mushrooms in the neighborhood. So the next option, what we're gonna try, is the vacuum technology to grab these champion mushrooms. Okay, thank you very much, Andor, with this introduction, or for this introduction. I go back to my computer screen and continue my introduction with the RoboChair project. Okay, I'm here now. Okay, I'm back to the computer screen and start sharing. Okay, so please give me feedback if you can see my screen.
Yes, we can see it.
Cool. Okay, somehow it's not very smooth on my screen. Sorry for that. I don't know what could be the problem. I give another chance. Okay, so I share the PowerPoint presentation, and you must be seeing my screen correctly. Okay, so the RoboChair project is a Horizon 2020 project with multiple partners from Europe. You can see all the partners here. The goal of this project is to revolutionize the pork production through robotization and artificial intelligence, introducing a completely new method to produce pork meat. Today, the normal production line, automated or semi-automated production lines in the meat production, is a serial production chain going through all the steps from the intestine removal to the grading. And while the RoboChair philosophy is completely different. This is a parallel structure and a horizontally scaling structure in which 2 or 3 robots, it is not completely decided yet, performs all the steps of the production one by one after the other. In this model, multiple cells can be installed in a in a parallel way. So the scalability is based on a completely different concept. Óbuda University its responsibility is the gripper design, gripper design for the removal of the intestine and the plaque. So the two first steps in the production. And in this demonstration, we would like to introduce how our newly designed gripper operates. On this screen, this is an animation how the robots are going to perform the production steps. But if it is true, our colleagues currently performing a field test, and I really hope that they can join to the webinar. So I ask Bianca to switch them onto the public screen. The name of their camera is IROB X, is IROB external. Okay, hi Christoph, please introduce what you are doing now.
Hi everyone, I am Christoph. I am right now at Herzekolom at the Semmelweis University Slaughterhouse. I am outside right now, but I explained that what will you see, and then go inside. It's a bit noisy inside, so I am not sure that you will hear me well. But if you can't hear me there inside, I think Peter can explain in details what's happening. So what you will see is that we will like introduce what will happen in one of the cells. We are right now testing our gripper, the first prototype of the design gripper. So we will try to, or actually we will grasp the trachea here of the pig, and we will pull out all the intestines with this only one grasp for the trachea. After that, we will show you that with the same gripper, we can also grasp the limbs of the pig. We will grasp one already cut down limb, and we will move it away, showing you that it can withstand this more than 10 kilograms of weight. So now we will go inside. I hope that you will hear me there also. And I will switch my camera too. So I hope that you can see the pig now. This is the belly of the pig, and we have the saddle there. And here is our gripper. This is the gripper itself. And here is the trachea that I was talking about. You will see in a second that the gripper is grasping it. And now it's holding it. Yeah. Some more cuts is happening right now. And meanwhile, we are holding it with our gripper. Which... As you can see, the gripper is doing its job. The whole thing is together yet. And we can hold it quite firmly with it, and it can withstand this huge force that we need to tear out all the intestines. As you can see, my colleague is expressing quite much force. Jó? Még kéne egy kódtár, amivel föl tudsz tenni. Okay, so we removed the intestines. Now we will show you that we can also hold the limbs, the ham with it. There are the already cut limbs. It's more than 10 kilograms, 20, 12, sorry, 12, if I remember well. And it holds it well. Okay, so this was our presentation from the.
Okay, so
I
you.
hope you understood it.
Thank you very much, Christoph. It was amazing. It was a really live webinar. We just concluded that our gripper fulfills the requirements completely. So I'm especially happy now. Okay, so hopefully you are see us again. You are seeing us again?
Yes, yes.
Okay, so it was just a surprise, and we didn't want to disgust anyone before lunch, but I think this is a really a good involvement how we handle the research in a practical way alongside the theory. Okay, and the final presentation is this cake decoration. Sanyi, please start it. In the meantime, I introduce. So this is again our universal robot UR16 equipped with a pneumatic dispenser or of sugar cream, and using the robot manipulator and the pre-programmed decoration, we execute the cake decoration in an automatic way. Actually, this is not, again, not a very new technology. Industry wise, there are some manufacturers who can provide such functionalities in real industrial environment, but those techs are usually less affordable, need more expensive stuff, more expensive manipulator and dispensers. We committed to provide solutions for the small and medium-sized enterprises to make possible the setup of new production lines with ease. We had some problem here. There might be some air bubbles in the sugar, and that is why the robot didn't draw anything for a while. But now it's okay again, and the happy birthday caption on the cake is underway. Okay, the consistency of the sugar is not constant, so it influences the quality of the text pretty much. It requires a very serious setup. Some characters are readable at least. Okay, and thank you very much. This was the final moment of our presentation. If any questions, we are happy to answer.
Thank you, Peter. There were some questions in the chat box. Can you hear me, Peter?
Yes, I'm here.
So I will. So one question. The first question is, how can SMEs be somehow pushed or convinced that the robotics is closer to them than they think?
That's a very good question. We are communicating with SME leaders quite often, and they are not in an easy situation because the sales margin in this sector, especially in food and industries, is really small, and the risk of such robotization investment is high, and that is why the decision of a investment, the capital investment is very, very difficult. So our laboratory is open for cooperation before any serious investment to try out a new technology or existing technology and make it very clear and make a clear answer if the given technology is able to solve the task or not. And the programs by the government and by the EU can help a lot to answer these questions before starting to invest larger amounts in discovering these technologies. And I think this is the way how to go together with other living labs and with the SMEs to get funding to perform proof of concept validation projects and collect this experience on public surfaces, public websites to demonstrate that really the robot technology, the AI technology, the industrial information technology can solve real-world problems with a tractable financial background. So this is my answer, basically.
And there was another question, but this is my question. How so you partly responded to this in your presentation, but how do you see the role of a potential living lab in your ecosystem?
This question is already touched many times with Camden BRI, InnoScart, ELTE, BME, and I can transmit our common sense in this question, that if a local and international community cooperating with the SMEs and the stakeholders who deliver the problems, multiple living labs, or I don't know if it is one living lab with multiple agents or smaller living labs cooperating with each other. This is still a question to me, but as you see, we cannot cover everything in this spectrum. We need to cooperate with other agents who can try out, for example, industrial information technology in the BME Industry 4.0 laboratory, with AI technologies in the ELTE laboratory, or different other laboratories all over Europe or all over the world, and together in a joint force provide the answers to the companies in small and quick projects. I think the speed is very important. Nobody can wait 3 years to get an answer for a quite simple question. I think the reasonable project time frame is about 3 months in a small scale proof of concept, and then after a positive outcome, a larger project can be established and run, for example, for 1 year, and so on and so on.
Yes, and do you have currently some coordination mechanism planned between the Hungarian living labs that are presented today?
I think this is question to András.
Yes, I think we should come to this point later after my presentation.
But yeah. Yes, in short, this is to Roberto. Thank you for your question, Roberto. Yes, we have some coordinated mechanism and plan. Yes, but this is the short answer. And while sorry, András, just one. Sorry.
Yes, I mean, you are moderating or I, because I'm a bit lost now.
No, you are moderating, sorry.
So, please continue, or shall I start, or where we are?